cloud. Beautiful. Um, so before we have Andres talk about his new project idea, just quick overall announcement on the lines of AGU. PyHC has a session. If you think you'll be able to come at all, I suggest submitting an abstract. We don't know yet, obviously, if it's a poster or talk session. Got to wait for AGU to assign that later. Um, Other than that, I don't have anything else. Sean, do you have any updates for the folks before we start?
I don't think I have anything this time. Um, maybe a
Okay.
quick question on AGU. You're expecting me to come there in person too with that, right?
Yeah, we usually have money in the grant for you to go to.
Yep, cool. I was gonna be looking into that real soon.
Okay. Yeah. I'd go ahead and start booking.
Yep.
Um, cool. Well, without further ado, Andres, would you like to tell us about what we chatted about over the REU Bootcamp week?
Yes. So, okay. Let me share my screen. I have a short presentation, kind of like explaining a little bit what the idea is, and then I'll give you like a quick update of where we are. Okay. Lately, I have been like fascinated with the idea of using AI models as a way to measure things. So typically, the data, what we measure is not what we want to know. So, for example, if you think about ultraviolet, so when we make measurements of ultraviolet, AIA, or SUVI, different channels, we are measuring photons. But what we really care about is densities and temperatures. And that is true for a huge majority of our remote sensing. Remote sensing is an indirect measurement of something we actually want to measure. And so, and so as part of this project that I'm in, I have come to the conclusion that we need differentiable coordinate transformations because they are part of establishing connections between what we want to measure and what we want to know and what we can actually measure. So the idea is basically is the following. So we have what we can measure, and we want to establish. Okay, no, sorry. Let me go back. It's a little bit. When we're talking about machine learning or AI, we're basically establishing relationships between data. Okay, and approximating those relationships mathematically. So if there is a mathematical like for expression or formulation or function that enables the establishment of this connection, that's what we want to approximate. And we do this by putting a differentiable model that transforms one of the data that goes in into the data that goes out. And we have a loss or error function that we optimize against. So we look at how different is what the model is giving us from where we want to get. We quantify that, and then we can improve the model in a loop, hopefully to our satisfaction. And all this is possible when we have everything is differentiable. And the idea that any set of transformations that converts the input data into that output data, it can be perceived as a nested set of equations. And it can be anything. This nested set of equations can be, anything. The only condition is that every one of these functions is differentiable. And so this allows us to take the learnable components of our model and take derivatives of our optimization against every single one of them so that then we can optimize this. But the thing that to me has become really fascinating is that when I started doing AI almost 10 years ago, I always kind of like was mentally, without realizing, mentally trapped in the idea that AI involved well-established and understood architectures like the multi-layer perceptron or a convolutional neural network or a long-term, short-term, short memory or a transformer, etc. But in reality, we have like control here. And that's, I think, what I would like, what this kind of project aims to unleash. So I have found very useful to think about these kinds of models in terms of encoding, a latent space, and a projection. So you take your input data and you execute a series of operations upon that input data. And that maps that data into a mathematical space that is not necessary, that is not the original one. And it can have different properties and different mathematical kind of like implications. And then you have another part of your model that projects that space into your target, into the establishing, finishing the connection that you want to establish. The cool thing is that thinking about it this way, physics can go in like in many different places. So we could have where everything here started for me is having a latent physical space. So if you have a model that at some point gives you the quantities that you actually want to know, then you have a model that is kind of like broken open because you're actually learning what you want to actually learn. So you could have ultraviolet photons here. You can have a latent space where you actually have densities and temperatures. And then your output could be, for example, other or ultraviolet again. So these kinds of things are kind of like what I would like us to enable. But now I have realized that because these transformations, as long as they're differentiable, are can be made part of any model, then this opens a huge world of possibilities. For example, a physical space transformation can be considered part of your encoding. So for example, right now I'm working on a project that wants to learn flows on the surface of the sun. But our input data, magnetograms, exists in helioprojective coordinates. But my latent space exists in heliographic, latitude and longitude. So I can project these, and the coordinate transformations are differentiable. It's just trigonometry. So you can have physical transformations that put the rest of your model existing in heliographic on the surface of a sphere, take advantage of the fact that you know that you're working on the surface of a sphere. And then in order to make the connection with your target, you can do a transformation again. So for example, I can have a model that transforms the images into heliographic, does surface flux transport, which will be part of this, projects back into helioprojective and compares an error against an HMI observation, a magnetogram in the future. So these are like the kinds of things that I think we would like to enable. So right now, machine learning in heliophysics typically it's very image space focused and all lives in helioprojective. People do segmentation on images, people do calculation on images, differential emission measure on images. Everything happens on the images themselves. People never leave that space in machine learning. The other thing is that you can have classical models that are differentiable as part of this whole structure. So for example, a finite differencing time advancement step is differentiable. So you can take a step into the future using classical transport as part of your model, and you can back propagate through that. So putting the whole end-to-end thing in these kind of frameworks allows you a possibility to learn physical parameters that I think is unprecedented, because your calibration between instruments can be part of your encoding and decoding. So you can have a model that can learn physical quantities from HMI and MDI and GONG at the same time. Because you get the calibration for free because it's learnable. Optimization, even optimization steps are differentiable. So right now, I'm trying to implement like a differential emission measurement where your optimization step is backpropagated through. Like a Newton optimization step is differentiable. So you can have an optimization happening within your differentiable model and backpropagate your error through it. So that's kind of like the idea here to enable these kinds of things. Of course, you can also have physical objective functions, and this only adds more flavor and power to the thing. For example, that's the way pins work. Pins, physics informed neural networks work, where you take advantage of your understanding of your physical constraints, like a field has to be divergence free, or having conservation of mass and momentum, conservation of energy. You can put all these things here in your optimization and enable that backpropagation through this. So just to give you an example, what I was saying, having a differential rotation kind of like that takes advantage of coordinate transformation. So you guys probably know the sun rotates differentially, the equator faster than the poles, and these effects clearly can be seen when you look at movies and long-term kind of evolution of the sun. So in this context, this is what I was saying. We can learn our latent space can exist in heliographic, and our coordinate transformations are part of encoding and decoding. And we can have the flux transport as part of my projection, and this will be the present and the future. So two pieces of data that exist separated in time. And we can use like total unsigned flux, signed flux, magnetic range of influence. All these things can be made part of the optimization function so we can get that. And so the idea here, let me see if I have, okay. I think that's basically it, what I wanted to say. And I have a proof of concept where I was able to implement in PyTorch um, a coordinate transformation system that will take me from helioprojective to heliocentric to heliographic that gives identical results to SunPy. So, the latitude that I'm getting, the latitude that I get from SunPy, and the difference is literally zero. Now, this has other advantages in that you can take advantage of the GPU now to make coordinate transformations. So it significantly speeds up the coordinate transformation itself. So you can work in batches, multiple images at the same time, etc., etc. And so that's kind of like the project that I wanted to pitch. I'm working with an undergraduate student. I mean, he just finished high school. I don't know if he was able to join us today, actually. Maybe not. Um, but we found this framework called DF Reproject, which was developed by the Dragonfly telescope. And it was just really a reprojection model, just like and so, but the idea was so it has like WCS frames and et cetera, et cetera. And the whole for them the objective was just to be able to take advantage of the GPU. But we just submitted a pull request to them where we're actually enabling. So they will go from non-Pi arrays to PyTorch arrays, do coordinate transformation there, and then go back to SunPy arrays, non-Pi arrays, and that's what they will return. Like they will never like keep the PyTorch neither at the beginning nor at the end. It was just like to take advantage of PyTorch. But we just submitted a pull request to make it so that people could choose not to get back a NumPy array, but get back the PyTorch array with the whole backpropagation enabled. Now, this DevF project, it's focused on reprojection on plane of the sky. So it doesn't work for heliographic. It doesn't have at all the machinery, but we also have been able, I mean, by we, I mean Nathaniel. I was hoping he would be here. So this was a new development since last time when I prepared this presentation for you. Because the idea is to make this kind of like building a WCS kind of thing. Like the one that I show you was like hardcore, hard-coded Helio. So it was just designed, it will only work for the sun and nothing else. It uses some of the keywords from FITS, but it was really designed to go from helioprojective to heliographic and that's it, nothing else. But we found this and we're building on it so that you can do heliocentric Cartesian, heliographic, helioprojective, and also between helioprojective and also points of view. Mine was assuming you're looking at the sun, the observer was not moving, but to do something like stereo to SDO, what I implemented as a proof of concept was not working. But Nathaniel has made great progress. And it's working, it seems now, kind of like SunPy in some way, but all in PyTorch and enabling backpropagation. And so I just wanted to present this to you guys. And, I have not worked with PyHC at all. I know of it, or SunPy. SunPy work with it, but I have never contributed. So I think the question is what will be the next step and whether this should be a pull request to SunPy or it should be its own thing. We're of course kind of like building on top of this DF3 project, but we don't know if we want to try to push our changes so that it works for heliographic stuff, like for Helio stuff to them, or if we should use them as a dependency and build and expand within the context of SunPy or PyHC or, this is where like I have complete uncertainty. So that's basically all I wanted to say. I don't know what you guys think. Any comments, suggestions?
Thanks for giving us the overview, Andres. You mentioned maybe merging to SunPy. I see we have Jack on the call. Jack, what are your thoughts on that?
Andres, I think you need to add, like I'm cosplaying a SunPy developer here, so I think you need to contact the SunPy mailing list. So this is an interesting project, but I know that they try to keep the core of SunPy very, as small as is needed for functionality. So it's just, the team just doesn't have the resources to do that much more. But as an affiliated package, I think this might be a very interesting project. So I would encourage you to reach out to the SunPy developers and see what they say. Maybe you already have, and I don't know.
No. This is like, I have a limited understanding of the relationship between SunPy and PyHC. And so maybe you can also help me clarify that. I always perceive PyHC as something that aggregates all these efforts even beyond SunPy. And that's why I reach out to PyHC first. As you are here, like, in some way representing SunPy, maybe you have an opinion. I don't have a preference either way. Whether this should be its own package, an affiliated package, we should stay within the Every project, so in the Astro community, and just advertise it. Like, I have absolutely no idea what is the best way, or not even what are the pros or cons. So that's one of the things that I was looking for when I came to this meeting, like
Right.
guidance on that. Or
Well,
even clarification. Maybe I'm completely wrong on my perception of PyHC. So, like, maybe a clarification on that too, that will also.
well, Julie and Sean are here, and they're best placed to tell you about PyHC. Yeah, I would just like, at least from the SunPy side, I think just get in touch with the maintainers. But the DF reproject project is interesting. And I'm going to pass that on to the SunPy folks. I'm not sure that they know about this. So, and coordinate transformations have been a source of like a lot of effort has gone into them. So it'd be, I think, I'm not an expert in that, but we can get the experts to look at what you're doing and do more comparisons with SunPy. I'm sure that'd be very interesting. So yeah, I guess contact SunPy is the
next step.
Next step, yeah.
Do you think should you contact the steering committee, or is there a better email to use?
No, probably just on the main chat. Like if you go to sunpy.org, there's lots of connection, you know, how to contact, and then somebody will pick it up. And I'll mention this to I'll mention this to some people round about here, some Pi developers here. I'm sure they'll be interested.
Thanks, Jack. I see, Sean, you have a question in the chat. Is speed the main benefit of using machine learning for the coordinate transforms?
I will not say that. For me, it's not. For the Every project, for that project that I showed, yes, it's the sole purpose. But for me, that coordinate transformation, that doesn't break the gradient. So you cannot do coordinate transformation outside of the PyTorch or JAX or TensorFlow framework. The moment you step out, you make it impossible for the frameworks to backpropagate through what you did. And so, and then you cannot learn on whatever space is, or you cannot take advantage of that. To me, using PyTorch, that's what we're working with, PyTorch, but JAX or TensorFlow or whatever for coordinate transformations is that you don't break your gradient chain. So you can learn through anything. You can learn through coordinate transformations, so that your machine learning models can exist in a different space than your observations. That to me is the true power of this. But it does speed things up. Like that's a reality. But that was never to me. That was like a nice, cherry on top of the ice cream. But my motivation here is to enable us as a community to learn, to have complete freedom of the spaces that we want our models, machine learning models, to exist and learn. So you can imagine, for example, that's the other people that I have talked to. Punch. Punch has this crazy field of view that needs to be integrated. And the Punch pipeline, data science pipeline itself, needs to make a statement about the F corona as part of it. If you have everything existing in PyTorch, everything, the whole Punch pipeline, you can do at the same time you can learn your F corona alignments, shifts, rotations of the images to optimize like, and coordinate the field of view, etc. So the power of the benefit of this is the ability for you to learn whatever you want in whichever mathematical space you want. And that includes physical transformations of spaces if you want. So you can live in a different space than your data lives. Right now, AI/ML lives always in the same space that the data lives. Any transformation, any departure from the space that your data is happens in the obscurity of, non-physically interpretable architectures. You cannot get that out anymore. You have to just let it be in a bunch of weights and biases. But with these kinds of things, now we can take control of where we want things to be in between or in the middle of this learning kind of like entities.
Yeah, thanks for explaining that. That's just about right at the edge of the kind of math I can understand in this space here, but it really does sound like you had a kind of pretty deep epiphany in this, and by using machine learning to do this, you unlock capabilities that you don't get with the old way of doing coordinate transforms. So, I want to encourage getting this out there into people's hands as a tool somehow. Um, what's the best way to put it? Should it be its own package, or should it be incorporated somewhere else? Is obviously a discussion we can have as a community.
Okay, so I will talk with. Okay, is there anything more that you guys think I should do besides contacting Sunpy?
Not off the top of my head. I think that's a great place to start. I'm just wondering, were you part of the decision for the license chosen for the project, the software license?
But you mean DF3 project?
Yeah.
No, from DF3 project, no, because that is part of the why?
I'm just curious because I saw it was GPL and we usually don't recommend copyleft licenses, but maybe there's a good reason why that particular one was chosen.
Do you mean in this one? No, I was not part of that decision. So that means, yes, we will have to use that same license, right? Yes. Yeah. Okay, I think that was it. The last thing is though, since you mentioned it, Julie, we also submitted we may be merged. We may be merged. We also submitted an AGU session on AI infrastructure. So think reusable things that enable AI. So anything that involves the creation of AI infrastructure, anything, like anything and everything. Teaching, schools, frameworks, data and applications of it. So somebody that is using anything for machine learning that is reusable infrastructure also fits in our session. So just in case you guys have either through, like, I guess if you have a PyHC, you will submit to PyHC. But if you guys have anything regarding machine learning, reusable machine learning infrastructure in any way, in any capacity, I also wanted you to make you aware of that session.
Yeah, sure. If you can send me the session link, I can
Yes, give me just
distribute
a
it.
second. Okay, I'll send it to you by email.
Sure, that works. Okay. Do we have any other comments for Andres based on his project description?
Would this be like, is it ready to be listed in PyHC, or is it already listed?
It's not listed, and I'm not 100% sure what we need to do to make it ready to be listed. I guess that's why I'm here.
Yeah, so the first step for that, if you think it's close to being ready to list, I see there's at least an initial release here from April of this year. If you go to pyhc.org and then go to our project page, there's new project edition instructions, and in there's a template for the different things you'll be looking at and kind of self-grading yourself on, for how well it fits to our standards or not. That'll be a good way to see kind of where you line up at the moment.
So this would be in PyHC where? In projects?
Yeah, so PyHC.org.
Uh-huh.
There's the share button. Boop, boop, boop. Of course, my toolbar is right in the way. All right, I have the screen minimized right now, so it's hard to see, but if you go to projects, add a
Okay, okay.
project, all of that. And then, I mean, in there, it mentions it, but also you can just go here to see what our standards are and get kind of an idea of where you might fall under that umbrella at the moment.
Okay. And there is like so I do these project addition instructions, and I follow those instructions, right?
Yeah, that's what you do. It's pretty straightforward once you kind of, take a look through the standards, self-grade, all of that. There's a nice project template submission form that you can use to
Mhm.
make a PR on our GitHub for.
Okay, perfect.
Yeah, it's pretty straightforward. I'd start. You can look at that and also then just email or I guess get on the chat group for Senpai to talk with them about it. Sorry, I also noticed that John has a comment in the chat. Do you want to just speak up, John, or should I just?
Oh yeah, I'm just going digging, like since DF Reproject claims that they're kind of coming off of AstroPy Reproject. The AstroPy Reproject is actually 3BSD based. And
What's 3BSD?
the
3BSD?
3 clause BSD, it's a pretty good license. And I'm looking at the initial commit on DF Reproject as MIT license. So if we can't convince the authors that this is a bad idea, it's probably possible to just re-implement. Hate to suggest it, but it's possibly a ways forward.
Can you guys elaborate the issues with the licenses?
It just is as soon as you pull in something that's GPL based, you're spending a lot of effort making sure that you're compliant with that all the way down the line, making sure that nobody ever has, basically, you are limited in what you can do with the compiled code after that point, as soon as you bring anything GPL. And so it puts quite a few restrictions on anybody who's doing any further redistribution.
But the authors of the Free project could change it if we request. Is that a correct statement?
Yeah, I mean, it looks like there's like 3 contributors, so they could yep, so they could relicense. All it takes is for those 3 people to agree. Of course, it looks like they explicitly went to GPL at some point in the process, so I'm kind of trolling through the history to find out if there's any indication why.
Mm-hmm.
But it is probably a conversation worth having since this is, only a few months old.
Okay. I mean, I can ask them, but if they say no, I don't think we have the resources to necessarily. I mean, finding them and taking advantage of what they have built has been a significant boon for us. So, there is no harm in asking them, but if they say no, we'll just have to stick with it for ourselves. Somebody else can re-implement.
Yeah, so they found, that's the commit. Can we get the PR out of this? Yeah, they just the con is just updated paper in April. They went and just changed the license.
Okay.
So
So MIT will be your suggestion?
I mean, they started with MIT. Like we generally like one of the BSDs, but yeah, and maybe it would make sense for somebody from PyHC to be involved in that outreach if that would help to be able to explain it.
Okay. Well, I don't know. I can meet with. I don't know them personally, actually, and so I guess I will have to start first getting to know them. So I'll let you guys know. I'll definitely keep this in feedback in mind.
And also
I need
looks
to
like,
also know.
so,
Go
sorry, it
ahead.
also looks like they're trying to work with JOS. It's hard to tell. They have pull requests that have absolutely no description. Um,
With Jax?
JOS, Journal of Open Source Software.
Ah, okay. I'm not familiar with it.
It's basically what it sounds like. It's a journal that exists to review, and that's, includes technical review, including issues like licenses, open source software, and get a publication out there. So this looks like it's folks that are worth working with.
It seems like the concept of, using GPUs for accelerating coordinate transformations that's the key sort of idea, right? And then
For them,
yeah, for them, yeah. So
yes.
I mean, it
Yeah,
would
if you look at their codes, when you look at the code, they will do all the coordinate transformation in PyTorch, and the last line, the very last line, just before the return, they will cast it into NumPy.
right.
And so, our first pull request was like, hey, just let's put a flag so that you don't force it into NumPy at the very last, but you could return PyTorch, and that way you don't break the gradient chain for someone that wants to use it like we want. So, well, that and the implementation of like HDU lists that work with tensors instead of NumPy arrays. But yeah, the for them definitely this was never about machine learning, like, in the more modern sense. It was just about speed, 100%.
Yeah. I wonder if AstroPi would be interested in sort of looking at this as you know, an accelerator for the transformation graph in AstroPi. That would be, and then that would be, all across the AstroPi coordinate graph. And then the return that you request is just that'd be a simple thing.
Yes, I have not even considered talking with AstroPy. AstroPy does everything in C. So when the time comes to do all the transformation, it happens in C. But that definitely will break the gradient chain.
They have, I mean, this may go into the AstroPi reproject package, as this is kind of a fork of DF reproject is kind of a fork for a specialized case, but maybe it could be generalized up into AstroPi reproject. I don't know. Just
I think after talking with you guys, I'm going to schedule a meeting with the people from the Every project and see, just talk, because everything we have interacted with our interaction has been mainly just through GitHub. But we talk with them, and then, I can raise the issue of the license as well, and then see. But okay, I will also talk with the people from the Every project in person, like voice, like with face time, and talk with the people at SunPy. Look at the instructions that you gave us, and I think those are the 3 points, the main points, right? And I can just follow up with you guys after I know more.
Sounds great.
Okie doke.
Yep.
Awesome. Oh, and
And
sorry, go ahead, Sean. I can wait.
okay, yeah. I was just going to suggest too that if you get your software up to a point where you feel like it's working well and you're getting the benefits from, keeping the gradients, or the terminology you were using that I'm already forgetting, it might be worth coming back and giving a Telecon presentation on like the actual science benefits you can get from using this, because it sounds like you're thinking about coordinate transforms in a way that a lot of people aren't, and so you might be able to, get benefits from this approach that people just aren't even thinking of yet. And you could show us how to do it.
You mean in this? You mean here?
Yeah, certainly here at these telecons could be one avenue to do it, or just maybe consider putting together a conference talk or things like that.
What is that said? The thing that you said last?
Putting together a conference talk.
Oh, yes, yes, absolutely. Yes. Yeah, we'll definitely, yeah, we need to socialize this because I do think that once people start realizing the implications, it's going to be, it's going to be transformative in the way we do AI in Helio, for sure. Yeah.
Yeah, it sounds like it has the potential to be transformative, and I think part of a little bit of our silence is just that we're getting our heads wrapped around the concept for the first time, and but that's a good thing. We're all here to
Yeah,
learn.
it's to start the conversation.
Do you already have a package repo or anything made for your project itself? Or is this still kind of an idea in your head that
No,
hasn't yet?
we have a repo
Okay.
that we forked. It's a fork out of the free project.
Oh, okay. Okay. Cool,
Um,
cool.
you want to see it?
Uh, sure.
Let me see if I have. Let me see if I have. So this was set up by the student that I'm working with. I need to remember if if it is open or private. Give me just a second. Give me just, can you check if you can see this? I'm not seeing right now if I am.
It opened for me just now.
Okay, so that's it. That's the one. It's a fork of the every project, and we have been making modifications to it. And it has a branch called heliographic transformation. So that branch is probably where we are right now.
Okay, cool. I'll include that with the outro email.
And did I understand correctly that you're still working on training models to be able to do certain kinds of transformations, or have you already felt like you gave the example of the result that kind of matched SunPy's transformation, but then I
Yes,
think I heard you say some examples of times where your results aren't matching what you would expect.
they
Do I
are
remember correctly?
matching. Yes, correct. So I implemented this originally. I didn't know if this was like, I said, okay, let's try this. Can this be? Like I knew, can I do something like what SunPy does, but can I backpropagate through that? So that was that differential rotation model. And we're training it right now. So I don't have like the results, but it's like using AI to measure differential rotation and meridional flow, um, using the coordinate transformations and the SDO images. So that's something that we have right now is going on. But on this is on the other hand, but this is not based on the every project. So that's an implementation that will only work for SDO, basically, nothing else. Or Soho, like something that has all the imagers in the same viewpoint. It doesn't do the one that I was showing you first that is working on differential rotation will not be able to combine stereo and SDO. So I have that. It's going in, and it was not meant to. That one is not. It's kind of like not built necessarily. It's built kind of like as part of a project. But what I'm doing with Nathaniel is really trying to get it as a package. There is a project also associated with it. It's kind of like a topographic reconstruction of the corona, where we can look at the sun from different viewpoints, use coordinate transformations and radiative transfer in a corona to do reconstruction. So he's working towards that. But that one is actually on top of the every project, which in itself had been developed as a utility package, something that anybody can just do their coordinate transformations on. So that's what Nathaniel is focusing on. That one doesn't have yet a use case. The other one does, but it's more like it's not a utility package. It's just part of a project. Nathaniel is developing the utility package. There's something that this thing that could be like part of PyHC, but that one doesn't have an AI application yet. Does that answer the question?
Yeah, absolutely. And to that, I guess I'll just encourage you guys, say it sounds like you're doing awesome work, and I hope that the models you're training turn out to be successful models and are doing everything you want. And I think it's a great idea to contact, SunPy and AstroPy just to ask if they're interested enough in these methods to roll them into what they already have. And if those conversations don't go anywhere, then I would also just encourage you to, flesh this out as its own little, utility package, and PyHC would be happy to, bring you under our umbrella if that's the case.
Yes. Okay. Awesome. Yeah. That's. I'll definitely follow your guys's suggestions regarding this.
Awesome.
Great.
Cool. Well, I'm not seeing an influx of a ton more questions or anything. So thanks for your time and explaining this to us, Andres. And thanks everyone for coming. It was a bit of a suspense and mystery what this would be for you all. But I appreciate your inputs. Cool.
Thank you for your time.
Thank you again. See you all
Bye.
again. Bye, Andres. See you all again in 2 weeks. Same time, same place.